Good day, class. We are looking at a topic, gravitational field. And we can't just talk about gravitational field without having the proper knowledge of the basis. Are we together? Then, I would like you people to tell me the meaning of the law of attraction. The law of attraction. Who can give us the meaning of law of attraction? What is the law says?
Like object.
Like object.
Repel, attract,
Like object. Repel. Then unlike object attract. Do you get it? That is the law of attraction. And now that we are talking about the gravitational field, we can't just talk about the gravitational field without mentioning field itself. And what is field? Field is a region of space where the influence of physical quantities such as what? Electricity, magnetism, and gravitational force can be felt. Are we together? That is the meaning of the field. Then, to talk about the field itself, it has a force field which brings two objects together under the region of space on the earth. Are we together? And that force field is a type of force which is constant. If constant, do not need to touch the body of objects which they affect. Do we get it? That is the meaning of the force field. Then I told you that this force field divided into two parts. It's divided into scalar force field and vector force field. Are we together? And what is scalar force field? Scalar force field, I will give you as number one. Now, the meaning of scalar force field, it has only magnitude and no what? No direction. And I ask you people that what is the meaning of magnitude? Magnitude means what? The size of object. Are we together? Good. Then, the second one refers to the vector force field. And the vector force field has both magnitude and direction. It has both magnitude and what? And direction. And e.g. the example of this vector field is magnetism. Magnetism and then there's some gravitational field. Then electric field. So these are the good examples of vector force field. Okay? Now, in case you come across a question in your jam or work, they ask you that what are the following are the good examples of vector force field, except, then we can know that magnetism, gravitational force field, electric field are good examples of force field. Do you get it? Okay? Then we want to discuss the force field, gravitational field itself, which give us the so with this, the gravitational field is a region of space under the universe. Are we together? Now, if you look at the way I'm presenting this, I'm going in different dimensions and I'm still giving you the same point. Are we together? So gravitational field is a region of space where the influence of gravitational force can be felt on under the universe. Are we together? Then we are going to discuss what we know as Newton's law Newton's law of universal gravitation. Are we together? Hello? Now, you can see that we are taking this systematically, step by step, so that you will not know where you are going by the time you come across calculation. Are we together? Now, I'm going to introduce to you this law of Newton. And the law states that every object in the universe attract each other with a force which is directly proportional to the product of their masses and inversely proportional to the square root of their what? Of the distance in between them. That's the definition of the law. And mathematically, the gravitational force, which can be connoted as F, equals to G m1 m2 over r squared. Did you get it? Okay. Then where what? F is equals to by formula, and the formula is F equals to what? G m1 m2 over r squared. Are we together? And what is the meaning of the F? The F we have is gravitational force. Then our G is gravitational constant. While the M1 and M2 we see here is what masses of the object or particles. Are we together? Then the R is distance in between the particles. Are we together? Then this our capital G, it has what we call a numerical value as what? 6.67 times 10 raised to the power 11 minus 11 Newton per meter square per kilogram per meter square. Are we together? Then the essence of this formula is to prove to you that objects two particles, which is M1, M2, are attracted to each other by what we call gravitational force. Are we together? Okay? Now, the mass of this particle, like I said earlier, that what is the meaning of magnitude? We are discussing about the mass of this particle M1, then the mass of this particle M2. When they combine together with the forces, then something is happening to them. Are we together? Okay? Now, I will give you some examples with calculation. Now, with what we have on the board, the question says 2 5 kg spherical balls. Are we together? 2 5 kg spherical balls are placed so that their centers are 50 centimeters apart. What is the magnitude of the gravitational force between the two balls? Taking what G as this. Are we together? Now, who can tell me the first step to take to solve this? What's going to be the first step? You write your data. Under our data, you analyze what you are being given. What are the things given there? The mass is given, and which is how many? 5 kg. And don't forget that this mass we have it as M1, M2, which means M1 equals to 5 kg, then M2 also equals to 5 kg. Because it's not being specified that M1 has 5, then M2 has 10. Are we together? Since one mass is given to us, we are going to split it into 2. Are we together? Then what other things is given? Then the radius. Radius is 50 centimeters. Are we together? Then the G also is given to us as, let me just use it as gravitational force, gravitational constant. Gravitational constant G is given as 6.67 multiplied by 10 raised to the power 11 Newton per meter square kg square. Then, what other things is given? That's all. Then our force F is quiet or no. Is quiet or no. Are we together? Now, we are looking for force, and mathematically, F is equal to dm1 dm2 over r squared. Are we together? Okay? Then, by inputting what we have here into this formula, we can now determine our force. So we can rub this place. Now we are starting with G. That's the first, which is 6.67 times 10 raised to the power 11 raised to the power 11, then times M1, which is 5 kg, times M2, which is 5 kg. Then everything here over what? Over the distance, which is 50 centimeters. Then we are going to convert certain values. The distance given to us, we are going to convert it into, it's given in centimeter, we are going to convert it to millimeter, which is 50 over 100. Then it's going to give us 0.5. So at this point, we are having 6.67 times 10 raised to the power 11 times 5 times 5, everything over 0.5. Then don't forget it comes with square. Okay? Then with what we have now, then which is 6.67 multiplied by 10 raised to the power 11 times 25. Then everything here is going to give us 0.25. Okay, that's the value. 0.25. Okay? That's square of this 0.5. Okay? Then let me multiply 6.67 by 25. What is the value?
166.
It gave us 166.75. That's it. Times 10 raised to the power 11 over 0.25. Then divided by.
As times that is.
Don't just sit down.
67.
It will give us
667.
okay, now we are going to do something here. 166.75 times 10 raised to the power 11 over 0.5 times 10 raised to the power minus 1. Are we together? So we are going to have
667.
when you divide it by 10 raised to the power 11 minus 1. Are we? So, at this point, we are going to have 6.67 times 10. This is plus, are we? Then to give us minus 10. Then, don't forget we are dealing with force. Then the unit of force is what? Newton. That's our F equals to 8.